In this module, we will study about laws of chemical combination, which include law of conservation of mass, law of definite proportions, law of multiple proportions, law of reciprocal proportions, Gay-Lussac's law of gaseous volume, and Avogadro's law, along with Dalton's atomic theory.
An introduction.
Is the branch of science that deals with the composition, various properties and interaction. The entire universe is made up of matter. Everything around us, like book, pen, table, rod, water, air, sugar, etc., is matter.
Combination.
Chemical combination are as follows: law of conservation of mass, law of definite proportions, law of multiple proportions, law of reciprocal proportions, Gay-Lussac's law of gaseous volume, Avogadro's law. Law of conservation of mass, law of definite proportions, law of multiple proportions, and law of reciprocal proportions deal with the mass relationships of the elements. The Gay-Lussac's law of gaseous volume deals with the volume of reacting gases and the gases produced. Let us discuss these laws one by one.
Law of conservation of mass.
According to the law of conservation of mass, during any physical or chemical change, the total mass of the products is equal to the total mass of the reactants.
During a chemical change, matter is neither created nor destroyed. Consider the following example. 100 grams of mercuric oxide on decomposition gives 92.61 grams of mercury and 7.39 grams of oxygen. On calculating, we observe that the total mass of reactants is equal to the total mass of products, which is equal to 100 grams. Here is another example where we observe that the total mass of reactants is equal to total mass of products. Let us solve a numerical. If 8.3 grams of sodium bicarbonate is added to 21.1 grams of acetic acid solution, the residue, that is sodium ethanoate, and water is found to weigh according to the question. We can write the equation as follows. Now, we will calculate the mass of the reactants. The sum of the mass of reactants comes out to be 29.4 grams. Antoine Lavoisier established the law of conservation of mass. He carefully weighed the reactants and products of a chemical reaction in a sealed glass vessel. He explained that matter can change its state in a chemical reaction, but the total mass of the matter is same at the end as at the beginning of every chemical change. He heated precise amount of water to steam, which was brought into the contact with a red-hot iron barrel embedded in coal. The steam was cooled at another end in the form of water. The amount of water collected was less than that of used in the beginning. Simultaneously, a gas was also collected and the weight of iron barrel also increases. when increased weight of iron barrel and gas was combined, it was observed that this combined weight was exactly equal to the weight of lost water. He also observed that the gas collected was lighter than the air and it was flammable. The law can be verified with the help of Landolt's experiment. Landolt took the solutions of sodium chloride and silver nitrate separately in two limbs of H-shaped tube known as Landolt's tube. The two solutions were mixed by shaking the tube. Reaction occurred and a white precipitate of silver chloride was obtained. After the reaction, the tube was again weighed. It was observed that the weight remains practically unchanged. Take an example of mercuric oxide. 100 gram of mercuric oxide on heating gives 92.61 gram of mercury and 7.39 gram of oxygen. Hence, total mass of reactant is equal to total mass of products. Similarly, when 12 gram of carbon is burned with 32 gram of oxygen, it gives 44 gram of carbon dioxide. Hence, this law explains that in a chemical reaction, the total mass does not change.
To the law of definite proportions, a chemical compound always contains the same elements that are combined together in fixed proportion by mass.
Consider the following example. Carbon dioxide can be prepared by the following methods by burning coal in air. By heating limestone and by heating sodium bicarbonate. Thus, the given information can be summarized as follows. Let us solve a numerical. A sample of magnesium carbonate was found to contain 38.5% of magnesium, 24.2% of carbon and 67.1% of oxygen. According to the law of constant proportion, both the samples will have the same composition. Hence, the masses of magnesium, carbon and oxygen in 30 grams of magnesium carbonate will be mass of carbon is equal to 7.26 grams, mass of oxygen is equal to 20.13 grams. Hence, the mass of magnesium in 30 grams of magnesium carbonate is 11.55 grams. The mass of carbon.
Good morning, students.
Good morning, ma'am.
Let's start our chapter. Today we will learn about an important law, but before that, Harry, tell me the 3 different sources of water.
Ma'am, 3 water sources are rain, sea, and well.
Do you think that water obtained from these sources is different?
Yes, ma'am. Rainwater acts as an atmospheric purifier and it contains lots of pollutants. Well provides us with groundwater. It contains minerals such as iron, arsenic, etc. Seawater contains dissolved salts, or we can say that seawater is saline in nature.
But Harry, Do you know that good? Children, all of you look at the board and verify your calculations. Ammonia is a compound made up of two elements, nitrogen and hydrogen. Atomic mass of nitrogen is 14U and atomic mass of hydrogen is 1U. So mass of one atom of nitrogen in ammonia is 14U and mass of 3 atoms of hydrogen in ammonia is 3U. Ratio of mass of element nitrogen and element hydrogen is mass of nitrogen upon mass of hydrogen, that is equal to 14 upon 3, that is 14:3. Ammonia is a compound which is made up of two elements, nitrogen and hydrogen, combined in the ratio of 14:3 by mass. Irrespective of that, it is prepared by Haber's process or any other chemical method, or produced by animals as excretory waste. A particular compound can be prepared by various independent methods. For example, compound calcium oxide can be prepared by the following 3 methods. By heating calcium carbonate strongly, by heating calcium hydroxide strongly, by heating calcium nitrate strongly. Now find out the ratio of calcium and oxygen in calcium oxide. Good. Calcium oxide is a compound made up of 2 elements, calcium and oxygen. Atomic mass of calcium is 40U and atomic mass of oxygen is 16U. So mass of one atom of calcium in calcium oxide is 40U and mass of one atom of oxygen in calcium oxide is 16U. Ratio of mass of element calcium and element oxygen is mass of calcium upon mass of oxygen, that is equal to 40 upon 16, that is 5:2. After analyzing calcium oxide prepared by different methods and sources, it is clear that it contains the elements calcium and oxygen only, and they are in the ratio of 5:2. Now let us solve a numerical and find out whether the given data verifies the law of constant proportions or not. In an experiment, 1.03 grams of copper provide 1.288 grams of copper oxide, and in another experiment, 2.938 grams of copper provide 3.672 grams of copper oxide. Show that this data proves law of constant proportions. In first experiment, mass of copper is 1.03 grams and mass of copper oxide is 1.288 grams. By subtracting mass of copper from mass of copper oxide, mass of oxygen is obtained as 0.258 grams. In the first sample of copper oxide compound, mass of copper upon mass of oxygen is 1.03 grams upon 0.258 grams, which is equal to 4:1. In second experiment, mass of copper is 2.938 grams and mass of copper oxide is 3.672 grams. By subtracting mass of copper from mass of copper oxide, mass of oxygen is obtained as 0.734 grams. In the second sample of copper oxide compound, mass of copper upon mass of oxygen is 2.938 grams upon 0.734 grams, which is equal to 4:1. From these two experiments, we can see that the ratio of copper and oxygen elements in the two samples of copper oxide compounds is same, that is 4:1. So we conclude that the given data prove the law of constant proportions. After going through all these examples, it is clear that a given chemical compound has same elemental composition. Now Lisa will repeat the law and the class will listen to her carefully.
A chemical compound always consists of the same elements combined together in the same proportion by mass, independent of the method by which it is prepared or the source from which it is obtained.
Multiple proportions.
According to the law of multiple proportions, when two elements combine to form two or more compounds, the different masses of one element which combine with a fixed mass of the other element.
For example, the mass of oxygen that combines with a fixed mass of carbon, that is 12, bears a simple whole number ratio, that is 16:32 or 1:2. Consider another example. Compounds of sulfur and oxygen. In these two compounds, the ratio of the masses of oxygen that combines with 32 parts of sulfur is 32:48, that is 2:3, which is solve a numerical. Carbon and oxygen are known to form two compounds. The carbon content in one of these compounds is 50%, while in the other compound it is 40%. According to this question, in the first compound, the percentage of carbon is 50. It means that 50 grams of carbon combines with 50 grams of oxygen. Thus, on calculating, we get the amount of oxygen that is equal to 100 grams. Good morning, students.
Good morning, ma'am.
Students, you know atoms of same element or different elements combine in fixed ratio by mass to form various compounds. Do you know that the combination of elements to form compounds is governed by 5 basic laws? Can you name them?
The laws are Law of Conservation of Mass, Law of Definite Proportions, Law of Multiple Proportions, Gay-Lussac's Law of Gaseous Volumes, and Avogadro's Law.
Let us discuss the law of multiple proportions. This law was proposed by John Dalton in 1803. The law states that when two elements combine to form two or more compounds, the masses of one element that combine with the fixed mass of the other element are in simple whole number ratio. Hydrogen and oxygen are two common elements. These elements combine to form two different compounds, namely water and hydrogen peroxide. Water is formed when two atoms of hydrogen combine with one atom of oxygen. Atomic mass of an atom of hydrogen is 1 U and that of an atom of oxygen is 16 U. So, mass of two atoms of hydrogen is 2 U and mass of one atom of oxygen is 16 U. Ratio of masses of hydrogen and oxygen is mass of hydrogen atoms upon mass of oxygen atom, that is equal to 2 upon 16, that is 1:8. Hydrogen peroxide is formed when two atoms of hydrogen combine with two atoms of oxygen. Here mass of two atoms of hydrogen is 2 U and mass of two atoms of oxygen is 32 U. Ratio of masses of atoms of hydrogen and oxygen is mass of hydrogen atoms upon mass of oxygen atoms, that is equal to 2 upon 32, that is 1:16. In case of water molecule, ratio of hydrogen to oxygen is 1:8, while in hydrogen peroxide, this ratio is 1:16. Now if we fix the mass of hydrogen as 2, the ratio of masses of oxygen that combines with hydrogen in water and hydrogen peroxide will be 8:16 or simplified to 1:2. This data proves the law of multiple proportions. Now let us find if we can verify the law of multiple proportions by fixing the mass of oxygen atom in water and hydrogen peroxide. If we fix the mass of oxygen at 16, the ratio of masses of hydrogen that combine with it in water and hydrogen peroxide will be 2:1. Hence, this again proves the law of multiple proportions. So, have you all understood this law?
Yes, ma'am.
Good. Now let us solve a numerical based on this law. When copper oxide is heated, it forms copper and oxygen. In first experiment, when 1 gram of copper oxide was heated, it produced 0.888 gram of copper, and in second experiment, 1 gram of copper oxide gave 0.799 gram of copper. Show that this data prove law of multiple proportions. In first experiment, mass of copper oxide is 1 gram and mass of copper is 0.888 gram. By subtracting mass of copper from mass of copper oxide, mass of oxygen is obtained as 0.112 gram. It means 0.112 gram of oxygen combines with 0.888 gram of copper. To calculate the amount of copper that combines with 1 gram of oxygen, find the mass of copper upon mass of oxygen, that is 0.888 gram upon 0.112 gram equals to 7.93 gram. In second experiment, mass of copper oxide is 1 gram and mass of copper is 0.799 gram. By subtracting mass of copper from mass of copper oxide, mass of oxygen is obtained as 0.201 gram. It means 0.201 gram of oxygen combines with 0.799 gram of copper. To calculate the amount of copper that combines with 1 gram of oxygen, we will calculate by finding the mass of copper upon mass of oxygen, that is 0.799 gram upon 0.201 gram, which is equal to 3.98 gram. The ratio of masses of copper that combines with 1 gram of oxygen is equal to 7.93 is to 3.98, which is equal to 2:1. This is a simple whole number ratio. Hence, it verifies law of multiple proportions. Now Jasmine will repeat the law and the class will listen to her carefully.
When two elements combine to form two or more compounds, the masses of one element that combine with the fixed mass of the other element are in simple whole number ratio.
Law of reciprocal proportions. Learn about the law of reciprocal proportions. The law states that the ratio of masses of two elements that combine separately with a fixed mass of the third element is either the same or some simple multiple of the ratio of the masses in which they combine with each other. Consider three elements, carbon, oxygen and sulfur, that combine to form three different compounds, namely carbon dioxide, sulfur dioxide and carbon disulfide. Carbon dioxide ratio of masses of carbon and oxygen is 12:32. In sulfur dioxide, ratio of masses of sulfur and oxygen is 32:32. The ratio of masses of carbon and sulfur that combines with fixed mass of oxygen, that is 32, will be 3:8. Carbon disulfide ratio of masses of carbon and sulfur is 12:64 or 3:16. Two ratios marked as first and second are related to each other as 1:2, that is, the two ratios are whole number multiple of each other. Hence, it illustrates the law of reciprocal proportions. Solve a numerical. 61.8 grams of carbon combines with 80 grams of oxygen. 30.9 gram of carbon combines with 106.5 gram of sulfur. 13.2 gram of oxygen. To the given data, the mass of oxygen combining with 1 gram of carbon is 1.29 grams and mass of sulfur combining with 1 gram of carbon is 3. Of masses of oxygen and sulfur that combine with fixed mass of carbon, that is 1 gram, is 3:8. The ratio of masses of oxygen and sulfur which combine directly with each other is found to be 3:8. The two ratios are same, hence it illustrates the law of reciprocal proportions.
Gay-Lussac's Law of Gaseous Volume.
According to the Gay-Lussac's law of gaseous volume, when gases react, they do so in volumes that bear a simple whole number ratio to one another and to the volumes of the gaseous products. provided the temperature and pressure remains constant.
Consider the following reaction. The molar ratio for this reaction is 1:3:2. According to Gay-Lussac's law of gaseous volume, the molar ratio of the gases is equal to the ratio of volumes of reacting gases and products. 1 liter of nitrogen gas reacts with 3 liters of hydrogen gas to produce 2 liters of ammonia. Example 1. Formation of water. 2 volumes of hydrogen gas when mixed with 1 volume of oxygen gas give 2 volumes of water vapor at a constant temperature and pressure. Example 2. Formation of hydrogen chloride. 1 volume of hydrogen gas when mixed with 1 volume of chlorine gas gives 2 volumes of hydrogen chloride gas at the constant temperature and pressure. Let us solve a numerical. 40 centimeter cube of methane reacts with chlorine according to the following equation. Calculate the volume of hydrogen chloride gas formed and chlorine gas. According to the question, we have the equation as follows. Since 1 volume of methane requires 2 volumes of chlorine, 40 centimeter cube of methane will require 80 centimeter cube of chlorine. Thus, 80 centimeter cube of hydrogen chloride is formed and 80 centimeter cube of chlorine is required. Avogadro's law.
According to Avogadro's law, under similar conditions of pressure and temperature, equal volumes of ideal or perfect gases contain the same number of molecules.
Dalton's atomic theory. John Dalton, a British school teacher, published his atomic.
In 1803, a famous British chemist, John Dalton, proposed basic theory about the nature of matter. This theory is popularly known as Dalton's atomic theory. Let us learn about the postulates of this theory one by one. According to Dalton, all matter, whether an element, a compound, or a mixture, is made of very tiny particles called atoms. He also interpreted that an atom can neither be created nor destroyed. Atoms of the same element are identical in size, shape, mass, and chemical properties. Atoms of different elements have different sizes, masses, and chemical properties. Here, atoms of hydrogen differ from atoms of oxygen and nitrogen. Atoms of the same or different elements combine together to form molecules or compounds. Atoms combine in the ratio of small whole numbers to form compounds. Atoms of two different elements may combine in different ratios to form more than one compound. The number and kind of atoms in a given compound is always fixed. Later on, more research is carried out, which eventually led to the fact that atoms are made up of still smaller particles, protons, electrons, and neutrons.
Identify the law in which the total mass of the products is equal to the total mass of the reactants during any physical or chemical change from the given options, which are Law of Conservation of Mass, Avogadro's Law, Law of Definite Proportions, Gay-Lussac's Law of Combining Volumes, chemical compound always contains the same elements that are combined together in fixed proportion of mass, irrespective of its source. This statement is true according to which of the following options: law of conservation of mass, Avogadro's law, law of definite proportions, Gay-Lussac's law of combining volumes. Let us have a quick recap. According to the Daltons atomic theory, atoms are the building blocks of matter. Combination of different atoms is governed by the basic laws of chemical combination. Such laws are the law of conservation of mass, law of definite proportions, law of multiple proportions, Gay-Lussac's law of gaseous volume, and Avogadro's law.